Hey guys, in today's video we're going to be installing Klipper on this CR10S Pro V2 that is running Creality 4.2.7 mainboard. This process will not work for you if you're using the stock board. That has a different method for installing Klipper, and it involves a special fork of Klipper that was customized to work with the touch display. But in this case, we're using an Ender 3 V2 HD display, so the process is a little bit more straightforward. So let's jump into it. And guys, if you're new to the channel, consider subscribing, turn on your notification bell, and leave some comments. I love reading the comments and do my best to get back to you guys as soon as I see it. All right, let's start off with getting down some information. All right, guys, so we're going to have to grab some information here. First thing that we should do is head over to Advanced, go to Mesh Leveling, and we want to get the information on Mesh Inset. If you guys are running Miguel's professional firmware and you've been following this upgrade series for the CR10S Pro V2, you'll want to get this information. So we got a mesh minimum of 15 millimeters, mesh X max of 295. So just jot down that information. Y minimum is 15, Y max 305. Once you're done there, we're going to go back. We're going to go back again. We're going to go to probe settings, and you want to jot down your probe offsets. So currently I got X offset of negative 44 millimeters. Y offset is negative 8.7. And this one is very important, your probe Z offset, if it's already calibrated. That way we'll save some time later on. Negative 0.89. Next thing we're going to need is the physical settings. Bed size 310. The Y bed size is 320. X max position 345. And Y max position 320. Z max position 420. And that's all we're going to need. Alright, next thing I'm going to do is I'm going to shut down the printer and pull off the bottom cover. Alright, next thing we're going to do is start taking some of this stuff apart here. Currently I got the Ender 3 V2 HD display mounted up there, so we're no longer going to need that with Klipper, so I'm going to go ahead and remove that. And next thing I'm going to take off is old touch display and speaker. And the reason I'm taking this off is I want to reuse some of these standoffs, because we are going to need to mount the Raspberry Pi in here. I want to give a special shout out to Brad Smith. Thank you very much for donating a CM4, which is it's essentially a Raspberry Pi, but like a mini board with a little adapter, like a dock, and it's essentially a Raspberry Pi. Anyway, I'll show you what that thing looks like in a minute. Now, since I'm going to mount the Raspberry Pi up here, the Raspberry Pi is going to have to connect. The Raspberry Pi is going to have to connect to this micro USB, but I don't want to drill the case and have the wire go out and then connect in here. So I'm just going to relocate the main board. I'm going to bring it up. That way I can plug into it without having to modify the case. All right, so this is one of the parts that we made up, and just made this an on shape, and this is going to take up the opening here of the original display, and it's also going to give us a place where we can mount the Raspberry Pi. And I'll include all the STL files in the video description. That way, if you guys want to use this to do this upgrade, you can. Another part here that we're going to need is the adapter to mount the CM4 or Raspberry Pi. It's the same fastening points, whether it's a Pi 3B Plus or Pi 4 or a CM4 with a dock. The mounting points are the same. Alright guys, so here's the CM4, and it's essentially a little board that has the Raspberry Pi and all the processing components on it, and then it just gets fastened to this dock. This is kind of a cool little adapter. It has a place for a SSD drive. It's got a battery. Yeah, it's pretty neat. Alright, so I'm using a 90-degree adapter here, USB to micro USB, and this thing is about a foot long. We're also going to need a buck converter, and that's to power up the Raspberry Pi. So I already have it adjusted, and to adjust it, it's pretty simple. You're just putting 24 volts from the power supply on the inside, taking a multimeter and putting them on the output side, and then just turning this little screw on this little pot until you get the voltage to 5 volts. So 5 volts for the Raspberry Pi, and if you could also run the Raspberry Pi fan off of this as well if you wanted to. You can either use the 2 pins that are available on the Raspberry Pi, which are right here, or you can just piggyback off this output side. To mount the buck converter, I got this little part that I created in on shape, and it's gonna go right here where the speaker used to go. So it just pushes on there and then gets a few screws. The length of wire for the power plug. Now this little dock uses a USB-C, but a lot of Raspberry Pis use a micro USB. So just make sure that you take note of what kind of power plug your Raspberry Pi has. And this thing is about a foot long, the cable. And it's also, and it's about 18 inches, long for the feed side. So this is the side that goes to the power supply. I'm just fishing these wires over to the power supply. All right, next thing I'm going to assemble is going to be We need to relocate the fan. So I made up this little two-part adapter. So all it is the little standoff for the fan and the little plate that's gonna push onto these little pegs here. The fan just gets mounted to the bracket. Make sure you plug your fan in, don't forget that. And then lastly, the new mount for the control board. And I think before I plug this in, I'm probably gonna have to flash this first. We'll see. I don't know that I'm gonna have enough slack there. Yeah, maybe. Let's try. All right, so that's everything for the hardware pretty much. Just need to connect up the cable for the buck converter, and then we should be pretty much done in here. All right, one other thing I want to add to the Raspberry Pi, I'm going to try to just use one of these little stick-on heat sinks. But if this doesn't work out, I'm going to have to add a fan on here. And we'll try that for now. Probably in the next video, what I'm going to do is make up the plug for the ADXL 345 accelerometer. That way we can calibrate this thing properly and see if we can push some speeds. All right, let's jump over to the computer and I'll show you guys how to set up Klipper on the Raspberry Pi. All right, let's open up the Klipper files folder, and I'll have links in the video description for all these files, along with the STLs for the adapters to install a Raspberry Pi and the CR10S Pro V2. All right, let's open up the Ender 3 V2 Mainsail Klipper flashing guide. So just double click on that. I already got it open over here on the right. And we want to start off with the Raspberry Pi imager. If you don't have that installed, when you're looking at the flashing guide, there'll be a link right here in the first page. So you can just click on this download button and download the latest version. All right, I'm going to go ahead and open mine. Version, blah, blah. Okay, yeah, let's download the new version, just in case anything's changed. All right, so going back to the document here, let's make this thing a little bit bigger. Okay, we want to select Choose OS, and we want to select other specific purpose. We want to select the next thing is 3D printing, and we want Mainsail OS. And it looks like they got a new version now. It's a 64-bit one. Yeah, I'm going to go ahead and try the 64-bit version and see how it works. Next thing you want to do is choose the storage. And make sure that you have all your files off of it, because it will format the SD card. Next thing you want to do is click on the little cog here. Let's catch up with our instructions. And want to set up our host name. So I want to call this CR10S Pro V2. You want to enable SSH. Leave use password authentication checked. And under username, I'm going to change this to Pi. And then you want to enter in a password. And keep this password handy, because you're going to need it to get into the PuTTY session, along with WinSCP. Next thing you want to do is configure your wireless LAN. It's already picking mine up, but if it doesn't pick up yours, go ahead and fill it in. You could also change your wireless LAN country. Defaults to Great Britain. I'm just going to leave this alone because it doesn't bother me. Set local time zone. I'm in Central Time, so Chicago is correct for me. And then click Save. Once that's done, select Write. It's going to prompt you that it's going to erase the SD card. Select Yes. And this is going to take a few minutes. Alright, now that it's done, let's eject the SD card and place it in the Raspberry Pi. Let's plug in the printer. And switch it on, and hopefully everything will turn on. Yep, it's looking good. Now, the first time that you start the Raspberry Pi, it's going to take some time to expand the file system. So you just want to keep an eye on it. After a little while, you'll start to notice this little green LED is going to start blinking. Depending on the model Raspberry Pi you have, it may blink up here, or it may blink somewhere around there. There it goes. You see it blinking. All right, so let's head back over to the computer, and we'll launch Wireless Network Watcher. That way we can see when the IP address becomes available. Okay, we're done with the Raspberry Pi imager. We can close that. And scrolling down here on our document, on page 13, we're going to need a Wireless Network Watcher. There's a link in the PDF. You can click on it and download it. I already have it installed, so I'm just going to launch it. And what this thing is going to do is it's going to scan everything that's on the network. And I got a couple other Raspberry Pis running Klipper. So they're showing up over here. And here it is down here. Okay, so it showed up here. So what you can do is you can click on Properties. And you can either copy the IP address or we can copy the device name over here. We'll try with the device name and see if it works. So I'm just going to copy it. And you want to open your browser. Select a new tab. Right click and paste it. And you're going to need to, it may work like that. Let's try it like that. Just press the enter key. And there we go. So now Klipper is going to be in an error state. And don't worry, we're going to clear that up. What we can do in the meantime is let's go ahead and update this. So click on the machine wrench icon on the left side. And let's click on this little check for updates. It's going to refresh. Once it's all refreshed, click on Update All Components. And again, this will take a few minutes. All right, once it's done, you're going to get this connection failed box. That's okay. Let's go ahead and click try again. And all right, update is fully done. Go ahead and close it. It's going to restart again. Okay. Next thing we want to do is we want to come over here to this config file here. And you're going to click on the down arrow. And we want to select config_examples. And want to scroll down through this list. I'm going to go ahead and put all here. You want to scroll down in this list until you find the board that your printer uses. All right, so this is the one that we want right here. Generic Creality version 4.2.7.cfg. And I already have a pre-built one, but what we're after here in this with this file are the settings for flashing the firmware. So this is the important stuff. These are the important bits right here. So it says contains the pin mappings for a 4.2.7 board. We need to select STM32F103. So we're going to write that down somewhere. I'm just going to grab all of this right here. Okay, so we want this. And we want this part right here. All right, so we can get out of this for now. So just click on the X. Go to the dashboard. All right, so now we're going to start our putty session. So if we go back to our document, we've already done the update. Next thing we need to do is run putty. If you haven't already installed it, go ahead and click on the link and get both of these files. I'm going to open my putty session. And you can use, for the host name, you can use CR10S Pro V2. You can leave the default port. Make sure that SSH is selected. Click open. you're going to get this dialog box telling you that there's a security breach. This always happens the first time that you launch PuTTY with a new version of Klipper. Just select yes. The default login name is lowercase p, lowercase I. And the password that you selected in the Raspberry Pi imager. Once we're in the root menu, we want to come over to the document. We're going to select this first line, right click, copy, and when you right click in the PuTTY session, it's going to paste it. Then press enter. Let's get the next one. Copy, paste, enter. And this is the part where we're going to need this little thing that we got here. So this is the info that we got from that generic printer.cfg. First thing we're going to do is we're going to down arrow, right arrow, and then you want to down arrow till you get to this STM microcontroller STM32. Press the space bar. Down arrow again. And it's already selected the proper one. So this matches up with the notes that we took from the printer.cfg. So it's STM32F103. That's correct. Arrow down, arrow right, down 2 times to 28 KIB bootloader. Press the space bar. Down arrow, right arrow, down arrow again, and press the space bar to select serial on USART1 PA10/PA9. Now that all of our selections are correct, we're going to select Q for quit, Y for yes to save, and then we're going to go back over here to our document. We can close this notepad file. Next thing you want to select is you want to copy make, right click, copy, paste, enter, and it's going to build our flash file. All right, once our flash file is complete, we're going to scroll down to this next bit. Now, this part's important because this is going to ensure that we got communication between the Raspberry Pi and the control board. So go ahead and highlight this section here, copy, paste it into the PuTTY session, press enter, and you should get a response like this. If you get anything other than this, like directory not found, file not found, check the USB cable, because chances are the USB connection, there's something wrong with it. Either you have a bad cable or you have a charge-only cable. And I've had it to where I've gotten a cable brand new out of the package and the cable was bad. If you don't get this response, try a different USB cable, because when this thing doesn't give you this, when it doesn't return this data, it's 99% of the time due to the cable. All right, so let's scroll down to the next part here. Okay, so we're going to do a couple of updates. Let's copy this next line, sudo apt update, copy, paste, enter. It's asking you for the Pi password, type it in. Okay, next thing we're going to do is select the next line, copy, paste, enter. Let's select the next one. Enter. Okay, next one. Enter. Okay. All right, now we're going to install the software for the ADXL 345, which is the Klipper accelerometer. If you're not planning to use the accelerometer, you can skip this step. I highly recommend that you pick up the accelerometer because it'll make Klipper it'll take your Klipper to another level. Not sure why it's not letting me select this. Anyway, we don't need to change directory because we're already in the correct directory. So I'm just going to copy this line here. Copy. Paste. Enter. Select the next one. Copy. Paste. Enter. Select the next line. Enter. Copy, paste, enter. And you're familiar with this line because we were just here, but we're gonna change this to microcontroller architecture Linux process. So we're gonna down arrow one time, right arrow, down to Linux process, press the space bar, Q, Y, and then we're gonna go to this next part here. So we're at the bottom of page 17. I'm going to select this line here, right click, copy, paste, enter. Next line, copy, paste, enter. Okay, once that's done, we're going to select this next line, copy, paste, enter. All right, now we need the, we got to enable SPI. So for this, we're going to copy this next line, paste into PuTTY, enter. And what we need to do is we need to go to interface options. So we're going to down arrow, right arrow, enter. Down arrow to where it says SPI. Right arrow, enter. And then enter again. Enter one more time. Now we're going to press the tab key. Tab again to finish. Enter. And that part's done. All right, so now let's go back to Mainsail. And we'll bring in the printer.cfg. Let's reload this. Okay, what we need to do now is bring in the printer.cfg file. So from the config files folder, we're going to upload a file. Printer.cfg, where did I put it? Here it is. All right, I'm just going to bring it up. And I need to rename this. I gotta take that number 2 off. And okay, now what I'm gonna do is I'm gonna refresh this. I'm gonna restart the firmware. All right, there we go. All right, so we're up and running. Let's open up the printer.cfg and let's make some changes. So currently we don't have any errors. Okay, let's see our physical settings. X is 310. So we need 310 divided by 2, 155. So our center point is going to be 155. By 155. Actually, our Y is 320, so 320 would be 160, right? Yep. Okay, 160. So this first group of numbers is the X, the next group of numbers is the Y, and the 20 is the Z. Next thing we have to update is the BL Touch offset or CR Touch offset. In our case, it's 44, so I'm going to change that to 44. Our Y offset is 8.7. And again, we got to update our home position, so it's 155 for X and 160 for Y. Okay, our bed mesh minimum is 15. 15 on the Y. Our max is 295 for X and 305 for Y. Rope count is going to be 9 by 9, bicubic. All these look good. Okay, X max position is 345. Okay, our max for Y is 320. Our Z max is 420. And we're going to have to play around with our bed screws to get these all sorted out. All right, lastly is going to be the Z offset. And let's see, Z offset is 0.87. Oh, we're pretty close actually. All right. We got some bed mesh data in here, which we're gonna get rid of this. In this step, we're gonna flash the firmware to the printer. So let's go to our WinSCP shortcut. And from here, you want to select new site. Let's put in the host name. It's the one that we created during the Raspberry Pi Imager. So for me, it's CR10S Pro V2. Leave the port number default. Username is lowercase p, lowercase I. The password that you set up during your Raspberry Pi Imager session. select login, and on the right hand side you'll have the Pi home directory. You want to double click on this Klipper folder, double click on the out folder, and in here you're going to find a clipper.bin. This is the one that was generated while we were executing those different instructions in the putty session. So just right click your clipper.bin, copy it, right click on your desktop, paste. You'll get this dialog box. Just select OK, and then it's going to move it over to your desktop. So from here, let's go ahead and close WinSCP. We don't need this anymore. All right, from your desktop, let's right click on the clipper.bin, and we want to send it to the USB stick. But before we do that, let's format the USB stick to be sure that the flash is going to go smoothly. So I'm just going to right click on the USB stick, and I want to format. And we want FAT32 4096 allocation unit size. Give it a volume label if you want. Press start. It's going to prompt you that it's going to erase the USB stick. Click OK. Alright, once that's done, let's go back to the desktop. We'll close this. From the desktop, right click on your clipper.bin. Send it over to the USB stick. And then let's open the USB stick and confirm that it's there. Yep. Alright, let's head over to the printer and flash it. Alright, I'm going to shut it down because I got to unplug this this thing to get the SD card in here. And let's see, I think it goes like this. And I'm going to plug the screen back in, because how you can tell if it took the flash successfully is that the screen will be blank. So I'm just going to turn the printer on now. And if you can see, it's kind of hard to tell, but the screen is backlit, but there's nothing showing on it, which indicates that it took the flash just fine. All right, so once it's like this, go ahead and shut it back down. Unplug the display. Remove the SD card. And I gotta plug mine back in here. All right, turn it back on. And let's head back over to the computer. All right, I'm gonna save and restart. All right, let's go back to the printer, put the bottom cover on, and we'll try to home it and make sure everything is moving in the correct direction. All right, guys, so here's what the front cover looks like. So that just covers up the display. Let's type in the address of the printer, CR. All right, let's home it. All right, so all that's working. All right, guys, so let's PID tune the bed. And if we go back to our document over here, on page 26, we got PID calibrate heater extruder. So we're just going to grab this from the document, copy it, head over to our Klipper session, and in the console, we're going to right click and paste it. Now I'm going to change my target temperature to 215. I'm printing with a different filament. And click the send button. And this will take a few minutes. Once our PID tune's complete, let's highlight save underscore config, copy, paste it in the console, send it. Let's home the printer. And I like to do this because if I'm gonna be running the PID tune on the bed, I don't want the hot end along with the ducts really close to the bed. So I'm gonna move the print head up about 50 millimeters. And then let's go back to the document and we'll pick up the next one, which is the PID calibrate for the bed. So let's select this part here on page 27. Paste it into the console. The target's okay. Send it. And just like before, this will take a few minutes. Highlight save underscore config. Copy. Paste into the console. Send it. And we're done with PID tuning. Alright, what I'm going to do next is try to extrude some filament. So I'm just going to heat up my hot end to 215. Alright, what I'm going to do here is put a couple pieces of tape on the Bowden tube and the filament. And I want to see if the filament is moving in the proper direction. So in Klipper, I'm going to extrude about 20 millimeters of filament. And you saw that? Alright, so they went apart. So that means the stepper is turning in the wrong direction. So let me show you real quick how to fix that in Klipper. Alright, so one of the super cool things about Klipper is that you can make changes without having to recompile any firmware or even open up your printer and change the directions of the wires. You don't have to do any of that stuff. So what we're going to do is we're going to come over here to extruder, and you'll notice that it has a direction underscore pin, so dir underscore pin, and all we got to do is remove this exclamation point. That's it. Now save and restart. Go back to the dashboard. Let's set our heater temperature again to 215. And we'll confirm that we corrected the problem. All right, I'm going to reposition my masking tape again. And let's extrude another 20 millimeters of filament. Perfect. All right, so now we're moving in the right direction. All right, next thing I want to check is if we're flowing the proper amount of filament. And to do that, I'm going to measure off 110 millimeters. Let you guys up a little bit so you can see. So this little plastic part is 110 millimeters. So what I'm going to do is put it on top of the filament. And then just stick a piece of tape on there. And I'm going to extrude 100 millimeters of filament. All right, so back over here, we're going to go back to our document. And on page 28, it talks about rotation distance. So in here, we're going to come down to page 29, and on the third point here, we're going to issue a G91. So we're going to copy that, put it into the console, G91, check our temperature, okay, 215. Go back to the document, and we're going to copy this next line. So it's G1 E100 F60. G1, you got to take off this period here, and backspace, space again. All right, so it has to be just like this. Send it, and let's check on the printer and see what's going on. Now this little piece of plastic is 110 millimeters long, and that's where the tape was when we set it originally. We just asked the printer to extrude 100 millimeters of filament, so we should have something close to 10 millimeters left over, and that's how we're going to confirm if we're under or over extruding. All right, so I'm going to get my digital calipers, and I'm just going to measure out what's left here. And I got 10 millimeters, 0.14. So that's good in my book. So we don't need to do anything with the rotation or E-steps in Marlin. All right, so I'm just going to pull that off. All right, what we're going to do next is check our screw tilt calculate or bed tramming. So this is essentially going to probe right over each of the leveling screws to determine if our build plate is level with the gantry. And so before we do that, we need to home the printer. So I'm going to click on Home All. All right, so now we're homed. I'm going to go ahead and click on these little 3 dots. And the reason that this is here is because we have it built into the printer.cfg. So I'm going to go ahead and click on this, and I'll show you what's happening with the printer. So this looks good to me. I'm going to click accept. And you only need to adjust it really if any of the values are more than 10 minutes. Like in Klipper, these values, instead of being measurements, they're measured in minutes. So anything less than 10 minutes is acceptable. I like being closer to 0. So for me, a 0.01 difference is just perfect. All right, what we're going to do now is I'm going to move my Z up because I'm going to warm up the bed here. I'm going to move it to 50 millimeters. I'm going to set my bed temperature to 80. Now that we're at temp, let's go down to the console, click on the little question mark, type in bed, and we want bed mesh calibrate. Select it, send it, and let me show you what the printer's doing. Okay, now that that's done, save _config. But before we send it, let's check out our mesh. So you can click over here where it says height map. And this is what the thing looks like. It looks like a inverted potato chip. But you can see the maximum deviation is 0.307 millimeters. All right, so let's save that. Send it. It's going to restart the printer. And now we can jump onto Cura and load up a test print. Let me show you in Cura what you need to do to get this thing working properly, because I had Miguel's professional firmware and it works a little bit different. So if you click on the printer selection, you want to go down to where it says Manage Printers. And you'll notice there's a button over here that says Connect Moonraker. So Moonraker is the piece of software that allows Cura to communicate with the Raspberry Pi. So let's click on Connect Moonraker. And in here we got to put in the address to our Raspberry Pi. So for us, for this CR10S Pro V2, it's http://CR10S Pro V2, and then close it with another slash, and that's it. So now next thing you want to do is click on this tab that says Upload. And right now it's set up to only G-code, but if we select UPF with thumbnail, it will include a thumbnail along with the G-code. That way we can view an image of what we're printing when we're using the Mainsail interface with Klipper. So let's go ahead and close this. Close this. And also, if you're running any kind of scripts, again, this script was added in because of Miguel's professional firmware, but we no longer need it because the thumbnails will be automatically sent over along with the G-code. So we can just remove that script, close this, and here we have a model already loaded. This is a test square that I like to print. You want to make sure for this thing to print properly that under experimental, you have slicing tolerance is set to middle. If it's not set to middle, this thing won't slice. Another thing we want is under material, you want to make sure that you have the skirt brim flow set to 120%, prime tower flow set to 120%, initial layer flow also 120, and then under build plate adhesion, select brim, set the brim distance to 0.2, And that's all we're going to need here. So let's go ahead and slice it. So this is a 4-minute print. Also, what we can do at this point is we can increase the print speed. So let me come over here to speed. It's currently at 65 millimeters a second. We can run this at 100 easily. And later on, when we add the accelerometer, then we can push the speeds even more, because we'll be able to counteract any artifacts that are introduced into the print due to the extra vibrations from movements. So 100 millimeters a second, that's good. Let's go ahead and slice it again. And let's preview it. All right, and what's important is that we have this small gap right here. So this little white line here is going to help us fine-tune the Z offset. So we currently migrated over our previous Z offset, so we shouldn't have to make any changes to it, but I'll show you how this little gap shows up in the print. All right, let's select the little arrow. We're going to upload this. Wait a minute. Yeah, we're going to upload this to the CR10S Pro V2. Click on it. You'll get this little dialog box. Go ahead and check Start Print Job. Click Upload. And we got our confirmation. It's successfully uploaded and the print job is initiated. So let's jump back over to the printer and we'll check out and see what it's doing. So here's the little thumbnail. So if you look at that, it has a little thumbnail now, and you can click on it and see exactly what we're printing. All right, let's get this thing off the printer and check it out. Alright, so this is what you want your print to look like. So this is the bottom, and if you can see, you can see that slight gap there. That's what we're looking for. So that's the little 0.2 millimeter gap. So this is an indication of you're right on with the Z offset. If this gap was not present, like it was totally closed, that means you're printing too close to the build plate. If it's completely detached, that means that you're printing too high. So this is perfect right here. And if you were to print something with a brim, the brim is fairly easy to remove because this gap is present. So you can see it's not totally detached, but it's detached enough that it's pretty easy to remove, but not so easy to remove that it's useless as a brim. So there you go right there. Zoom in, maybe you guys can see. See that? That's perfect. Alright guys, the video's a wrap. If you're new to the channel, consider subscribing. Turn on your notification bell and leave me some comments. I love reading the comments. Do my best to get back to you guys as soon as I see them. In the next videos on the CR10S Pro V2 with Klipper, we'll be dialing in the pressure advance, adding the accelerometer, and fine-tuning the input shaping. Alright guys, till the next one. Take care.